Lecture 1.5 in the pre-algebra book, page number 41. The name of the lesson is Multiplication with Whole Numbers, and that's what we're going to be doing. We're going to be multiplying whole numbers, or basically numbers 0, 1, 2, 3, 4, 5 all the way to infinity. So those numbers are the ones that we're going to be dealing with today. First of all, let's look at something like 3 times 4. What that actually says. What that's actually saying is that we are going to take 3 and add it 4 times. It also says that we're going to take 4 and add it 3 times. So 3 4s or 4 3s. Doesn't matter what we're doing, but it's a simple way to add a string of numbers together quickly. So you already know 3 times 4 is 12. Comes real quickly. You memorize that probably in 3rd grade. But here, 3 plus 3 is 6, plus 9, or plus 3 is 9, plus 3 is 12. Or 4 plus 4 is 8, plus 4 is 12. Takes a little bit longer to do the addition. So the multiplication is just a simple way to do an addition problem. One of the things that I would really suggest, if you haven't done so at this point, is know your multiplication tables from 1 to 10 at least. If you can learn them 1 to 12, that would even be better. But knowing by memory, 2 times 5 is 10, 8 times 8 is 64, 9 times 7 is 63, and just memorize those multiplication tables, get them to where they come quickly and easily, and it will make math a lot easier. It will make the multiplication a lot easier, because you can't really do the multiplication simply and quickly if you don't know those multiplication tables, because when you get into some large numbers, you gotta know your multiplication tables. Several different ways to show multiplication. This is called notation, the way that we note multiplication. You're all familiar with this method, this x meaning times or to multiply. The problem with that when you get into pre-algebra and algebra and upper level math is this x here doesn't always mean times, it can mean the letter x. So it can get confusing on is this 3 times 4 or is this 3 times x times 4? So we don't use this very often in upper level math. We use various other ways of writing times. Probably the most popular is a dot. Not a decimal, a dot that's there in the middle. Sometimes on tests for me, if I have a keyboard that doesn't have a dot on it, I will use the asterisk sign there for a multiplication sign, but that's just me. Another way of writing 3 times 4 is 3 with a 4 next to it. Notice we put parentheses around the 4 so that it doesn't look like 34, but it's 3 in parentheses 4. If there's no sign, there's no operation, there's not a plus sign or a minus sign or a multiplication sign or a division sign, you assume that it's a multiplication sign. Because if you have a plus or a minus or a division sign, we're going to show that. But if I have that in parentheses and that in parentheses with no sign between them telling you what to do with the 3 and the 4, always multiply. And then you've got the old standby that you remember from when you were younger that looks like that. We are not doing away with this. This is still a very popular way to do multiplication when you have large numbers. So don't throw that out just because in pre-algebra we're using parentheses to multiply. So you may have them in parentheses, but you're going to end up doing it the long way sometimes. So anyway, in a multiplication problem, we have our answer, and we call the answer a product. Just like in addition, you call the answer a sum, and in subtraction, you call it a difference, and in division, you call it a quotient. Well, in multiplication, it's called a product. These numbers, any of the numbers that you multiply together to get your product, are called factors. So, This is a factor and this is a factor. So if I say, what are the factors of 72, I'm asking you, what numbers do I multiply together to get 72? So there's your factors, there's your product. And you can have two or more factors. You don't just have to have two. The next part of this lesson is on page 42. It's called the distributive property. And it is a particular property that you will be using the rest of your math life. What that property says is that if we have a 3, or any number for that matter, or actually any letter, and we're multiplying it by something in the parentheses, what this actually says is 3 times 4 and 3 times 5. We're taking this 3, not times just the 4, not times just the 5, but that 3 is being multiplied by what's inside the parentheses. In this case, there's a 4 and a 5. You may ask, why don't I just add 4 and 5 together and get 9 and multiply that by 3 and get 27? That works here. You can do that. Later on, that won't be possible. You won't be able to add these two numbers together because of the way they're set up. So that's why I'm teaching you this method now, is to get used to doing the method so that when you have to use it, when you have to depend on it, you'll have practiced it enough that you can do that. So what this means is this number times this number. This sign here always comes down. This number times this number. So we end up with 12 plus 15 equals our 27. That's called the distributive property. Alright, when you're talking about multiplication of whole numbers, you are familiar with single digit numbers. 4 times 5 is 20, 8 times 6 is 48, those kind of things. But what happens when you get a number like 52 and you want to multiply it by 37? Alright, just go real briefly into the old-fashioned way of doing this. And that old-fashioned way says, again, just like the addition and subtraction, you start out with the furthest to the right, and instead of add or subtract, you multiply these two numbers. And just like the addition, you only bring one of the numbers down. So 2 times 7 is 14. You bring the units digit down, the 4. You've got a 1 left over, so you put the 1 up here. Okay, now this is what's different than the addition. You don't multiply these. You don't add, or I'm sorry, you don't make this into a 15. You multiply, let me get a different color here. You multiply these, then you multiply these. So now we have 5 times 7 is 35, and then we add this 1, so it becomes 36. And since we're at the end, we're dealing with this last number here, we're going to write the whole 36 on here. So if there's nothing else over here, if you're at the last number, you write the entire answer down instead of like this one, 2 times 7 is 14, you just put the 4 here. You carry the 1, 5 times 7 is 35, plus 1 is 36. Now, we've multiplied these two numbers. We've multiplied these two numbers. Now we have to multiply the other numbers that we haven't multiplied yet. So the next step is you multiply these two numbers. 2 times 3. Well, because you're multiplying it by this 3 here, you look at the bottom. See, we multiplied 2 times 7 and got the 14. The 4 went under the 7. Well, since we're multiplying 2 times 3 and the 3 is over here, we're going to put that number under the 3, which in this case goes straight down below the 6. 2 times 3 is 6. There's nothing to carry. It's just 2 times 3 is 6. Well, now we're going to multiply 5 times 3 and get 15. Again, we're at the end, as far left as we can go, so we're going to put the whole 15 there. And now we're going to add. And we get 1,924 when we're done. Alright, so we weren't far enough to get done with the lesson in that short 10 minutes. So I'm going to turn the video off and run part 2 of section 1.5 and continue on with this lecture.